Here's a video on tearing down a laptop battery to reclaim the 18650 cells. So first, this is just a regular laptop battery pack, and it's bad. Doesn't operate anymore, doesn't power the laptop properly. And first you probably want to start off with a discharged battery. So you can see that says negative and that says positive. We'll put this on DC volts and we'll measure it to see if it is indeed empty. And you can see there we pretty much have no voltage, so this pack is pretty dead. And to get these open, you just kind of find a seam along here and you can kind of pry at it a little bit. In this particular pack, it's kind of easy to get under this side. Let me grab a screwdriver here, see if I can get maybe. This particular laptop battery, this little piece here is a circuit board that does the monitoring of the cell voltages and the charging currents and gives feedback back to the laptop as to the time remaining and the battery charge and etc. And we will just peel this apart and you can kind of see that circuit board under there. There we go. The cover is off. And we'll peel back this tape and you can see the 18650 cells. And the 18650 cell, or the naming convention, is it's 18 millimeters in diameter and it's 65 millimeters long, and the 0 is just an extra digit, presumably if they had one that was longer than 100 millimeters they could go to that many decimal places. Again, you want to make sure that your cell pack is depleted before you take it apart like this, because if it's not, then you have to be very careful not to short any of these battery pieces out, otherwise you'll have a large current discharge and you could potentially cause a fire or something like that. Not good. As we tested originally, this pack is depleted, so these batteries are not going to have a charge on them, which would cause us trouble. Here you can see the connection that would go to the laptop, and you can see the monitoring and control circuitry here that handles the charging of the batteries and such. So this little piece right here is a thermistor, and it was taped to one of the batteries there, and it measures the temperature of that battery. So if that battery were to overheat, the circuitry would be able to see that, register that through this temperature sensor, and the control circuitry would cut off the voltage to the batteries, so that reduced the risk of fire. So now we're going to cut these apart. So I'm going to start by chopping the circuit board off. So let's see if I can do that. It's connected there, there. There. Oops, I could have a little jumper wire there. So there is the control circuit board. We'll set that aside. And so now we have the batteries. And as you can see, they are configured in a parallel series. So these three are in parallel, these three are in parallel, and these three are in parallel. And since these batteries have a voltage rating of 3.7, it would be 3.7 plus 3.7 plus 3.7, which would be 11.1 volts total. And if we looked at the battery pack on the, let me get that cover back here, on the specs of this battery pack, it says right there 10.8, 11.1, about the same, and it has 7.8 amp hour rating. So fully charged, these are 3.7, so they should be about 11.1. The battery pack is supposed to be 10.8, and then the 7.8 milliamp hours is the 2.1 or 2.4 milliamp hours per section. So it's 2.4, 2.4, and 2.4 is about 7 point something or other. So maybe these are supposed to be 2.5, but anyway, that's how they get the rating. So when you put them in parallel, you get more amp hours, you get more capacity, and then when you put them in series, you get more voltage. So that's why they do them in series parallel like this. So as you can see, these metal tabs they're not soldered to the batteries, because it's hard to solder to these batteries because they have so much thermal mass that it's hard, and you really don't want to get these batteries hot if you can help it. And so what they do is they spot weld these little tabs. So they put a tab, these little flexible tabs, they put them over the battery, and then they come in with a little spot welder, and it just quickly spot welds it to the back of the battery. So that way it restricts the heat to that one little area and doesn't put any kind of a thermal stress onto the battery, because you really don't want to heat these lithium-ion batteries up. Heat is not a friend to them. So there's three in parallel, there's three more in parallel, and then those. So to get these off, you kind of, like an old sardine can, I take my pliers on there and I just kind of roll it off and just peel the thing off, and it leaves sometimes, I don't know, you may be able to see that right there, it'll leave a little sharp piece of metal, and you can either trim that off with your cutters, and so I try and trim them off as best I can. If I can't trim them flush, they're still kind of sharp, and so I'll take them and press them down on a table, and that kind of flattens them out to where they're not sharp and damage you. So there's one cell that we've just liberated from the pack, and remove this little tape here. This tape is a high temperature, it's called Kapton tape, and it's a nice high temperature tape that you can use to insulate these, and it doesn't melt or catch fire. And again, we're just going to peel these off, again kind of like a sardine can, just kind of get there to where it's attached, and just kind of roll it off till it comes off. Get this trash out of the way here. We'll do the same thing here, just roll till it comes off. Roll till it comes off. And if you do this, you want to be real careful with these guys, because these are very sharp. And if you run these across your fingers or something, you can cut them very easily, and that's why I kind of mash them on the table there, and then they kind of become safe. So there is one more battery, and same thing here, kind of trim them off and flatten them a little bit, trim them off, and trim them off. Alright. And do the same thing here. eraser here. Set these down so they don't go rolling off. I've had good luck with these purple ones out of the laptop batteries. These seem to be a good quality brand. So, and this is a very old battery. This battery is probably 2 or 3 years old at least, if not more. So it's really amazing that these cells are holding any kind of capacity this long. You don't want to take this, you see this one's kind of ripped, this little plastic coating or wrapper here. You really want to leave those on there. They kind of insulate the cell from the other side, and they hold this little white piece of insulation on there to keep the negative separated from the positive there. So see, and there's the little sharp guys again. Just kind of work them down like that. And there's another sharp one. Okay, let's get those like that. Now, while the pack was putting out no voltage, sometimes these cells will actually still have some residual voltage on them. And that's kind of how you tell if they're going to be any good or not. If they're dead, they're probably, if they're showing 0 volts, then they're probably not going to take a charge and come back. At least that's what I found. So again, I'll take the little tape off. And there's a little hot glue on some of these sometimes, and you just want to carefully remove the hot glue. Sometimes I'll use a razor blade or just a scraper to kind of scrape the glue off. You just don't want to take it like that. You don't want to take off that little plastic wrapper, because again, that's what helps insulate them, the negative from the positive. So there's one. Again, this guy's kind of sharp. Let's clean it up. Mash it down flat, mash it down flat, and mash it down flat. Get that kinda. Okay, now you might say, why do we go to all the trouble of tearing up old laptop batteries to get these cells? A good quality cell like this, brand new, can be $6 to $10 a piece. That's why your laptop batteries are so expensive. So if you can reclaim some good quality cells from an old laptop battery, you're saving yourself quite a bit of money. And these cells, you can buy flashlights and other devices on eBay and online from China, and you could see they use these same little cells. These are the ones you would buy commercially, you know, without reclaiming them. And you can see that's what they look like. And these are Chinese cells, and they'll say that they're 3,000 milliamp hours. I don't know if you can read that there, but they're not. I've tested this one, and it's not even it's not even it's 300 milliamp hours, not 3,000, so it's not even close to being rated properly. And the same thing here, this one was 0.375 when I measured it. So this is 3,000 milliamp hours or 3 amp hours. So I measured 0.3 amp hours. So these are terrible. These are junk. And some previous cells like these, I tested them, and they were 2.228 milliamp hours. Sorry, amp hours, which would be 2228 milliamp hours. So these are very good cells compared to the cheap ones that you buy from China. These things, they're pretty much junk, and you know, you buy them for $4 a piece, and you think you're getting a good deal, but they're junk. They're terrible. So you can buy flashlights like this where you can use them. You can also get I think they can be used in those vape things. I don't vape, so that's where they can be used in. And then you can get other flashlights from China, that quite nice ones actually, aluminum with LED flashlights, and then of course you can use them. I actually had to modify this flashlight to use this battery. I actually printed this little sleeve, and this is another Reclaim battery from a laptop, so I actually modified this one. But you can get those things, and also power banks. You can get little USB power banks that you can buy them for a couple of bucks from China that have no batteries in them, and then you put these batteries in them, and then you can use them to charge your cell phones and things like that. So let's turn the meter on here. We'll turn it to voltage, and let's measure these cells. So this is the negative side, as you can see there, and this is the positive. So we will test these cells and see if they have any voltage. So start with this one. Look at that, 2.5 volts. That's going to be a really good cell. And I want to remind you, this battery has been sitting in my junk pile for at least a year or so. And they were originally manufactured at least 3 years ago, probably. So for that one still to have 2.5 volts on it, that's excellent. Ooh, this one also 2.5 volts. These are going to be a good batch. 2.5, excellent. 0.6. Now this one has some voltage on it, so you know, we'll put it, I'll tell you what, let's get a marker. Let's mark it unknown. Actually, let's mark it, let me find my magic marker here. So we know these three were good. Let's put a little dot on those for good. Let's put a little, I guess we'll put a red on this one, like unknown. Okay, so that one was 0.6, I believe. So it has some voltage, so it's not totally dead. These really good because the cell should never go lower than 2.5. So some of these will come back if they're low, but if they show 0, they're usually not coming back. This one also a 0.6, also a 0.6. Whoa, 2.8. So that's a good one. Okay, so let's put a little red on that one, a little red on that one, and then, wow, this one's going to get black because it's a nice one. And then 2.8. I imagine all these are going to be 2.8 as well, because they were, remember, they were in parallel, these were in parallel, and these were in parallel. So if you want to know why your laptop battery pack quit working, remember, let me get a piece of paper, draw this out. So let's take these guys, put them on this piece of paper, and then you can kind of see what happened here. So then we'll put a little thing there and a thing there. Okay, so the way this was working was this pack here was connected to this pack, and then this pack here was connected to this pack, and they were all together like this and that. So this pack here was 3.7, this pack here was 3.7, and this pack here was 3.7. So if you take a lead off there and a lead off there, you end up with 369, 11.1 volts, because you add these together. Now if you think about it, we just measured 2.8 here on these three batteries. I think we measured 2.5 right here on, I'll tell you what, let's leave that there. We'll put this as measured. And then these were 0.6 measured and 2.8 measured. So if you see what the circuit board was seeing at this point was 2.8, 2.5, and 0.6. So what's that? 3.1, 2.8 is 5.9. So instead of seeing 11.1 volts, the pack was only, the control circuitry was only seeing 5.9. So at that point it knew something was wrong in the pack, and it just quit working. It just said, I'm not going to try and charge this pack anymore. I'm just going to call it bad, and I'm going to blink the little battery light to tell you that the thing is bad. But in reality, these 6 cells are perfectly fine, but maybe one of these cells went bad and took that whole section out. So a third of this battery pack is still good. So it's kind of sad that, you know, you end up having to buy a very expensive laptop battery when only one little issue. It'd be nice if they had a way that you could exchange, you could pull the cells in and out of a pack, so you could just replace one little section or something. But anyway, so I'm going to charge these, and I will charge these up, get them fully topped off, and then I have a charger, I have a tester that will put a 0.65 milliamp, 0.65 amp load on them, and then it will measure how long it takes to discharge them, and then that's how we get our amp hour ratings. And what this means is this battery can put out 2.228 amps for 1 hour, or it can put out 0.65 amps for, you know, almost 4 hours. And so your normal cell phone may charge at 0.5 amps or maybe 1 amp. It draws that much current through a battery. So if you have one of these in a small USB charger, it will only be able to charge at that current for maybe 2 hours. This particular battery, because it has a good amp hour rating. This other battery, the cruddy one, since it only has 0.375 amp hours, it would only be able to charge at 1 amp, or, you know, for maybe 20 minutes or so, because the capacity just isn't there compared to this one. Like I said, these purple batteries out of these laptop packs have they're really good quality. And this battery isn't near as old as this battery. I don't know if there's a date code on here, but you know, this battery I've only had for maybe 8 months, or maybe a year, and this battery has been sitting around for at least 2 to 3 years. So anyway, I'm going to go charge these, and then I'm going to put them on the tester, and maybe I will do a video about showing how they are tested in the tester.